I want to keep time for discussion, so I will only show what is promised in the title, the new additions for this summer that I've selected for practice. But first, I want to make a few comments about why it is important. And Anna has explained the mission in total, and it's a really big task, and I try to phrase it in a short way. And the way I came up with to make it simple is to say that PLATO wants to detect a 1-1 planet and prove it. 1 Earth mass, 1 Earth radius, 1 year Earth orbit, once the age of our planet, so a planet of our age, and prove the age around a star which is one time the solar mass. And I often cannot believe that this is possible, but actually at the moment it's not possible. But if we do everything correctly, I think we can make it. And PLATO is the machine that will do it. I think there's no other hope for the next 2 decades, I think, to achieve that goal. So it's either this way or it won't happen. And it's a little bit like the lunar landing. It will happen if we do everything correctly. So if we do all correctly, this is achievable. So that is the end. And I'm responsible for a part that is, so to say, not for a specialist observer, but for that is very important. That is the first check of the candidates, and there will be many candidates, and all have to be checked, as Hans has just pointed out, in a very direct way, as you would see it on when you run your software. So we also have to make sure that these procedures work, because for a planet with 1 year orbit, there is once a year an occasion to check it, and anywhere on the planet, the transit will be in zenith anywhere on our planet. So the best position to observe will be unpredictable. Yeah? So only a huge swarm of telescope can achieve that. Because if we miss this one, the next opportunity is the next year. So this is the case for the citizen participation. This is my selection, and because Philip told me this should be a little more general selection than previously. Previously, I selected the toys to practice, because toys can be used for practice for PLATO, because essentially the magnitudes are the same. But PLATO is an entire different machine, so the periods are not the same, which is good because they happen often. So, and I selected it for direct detection, so a positive detection of the transit, and also for the procedure Hans has illustrated for the contaminants, these contaminating eclipsing binaries. But the most popular planets have not been of the contaminating kind of question for PLATO, but the ones that show a transit is actually detectable. And actually there have been many more detections than I'd expected, and much smaller planets than I expected. I put in challenging planets, and they have been detected, like definitely much smaller than Jupiter radius has been positively detected. And it's really nice for me to see all the names of the contributing observers, because you can see in the ETD, if you take the time with the toys, there are all sorts of fantastic results already. For example, you can immediately see that the original ephemeris that I put in are not good enough anymore, because you see the transit timing effect. So to the new candidates, it's now 60 new toys that are selected, and basically they are selected now to be easily accessible. And I put the list together by looking at the predicted tables for 4 locations on the planet. This is Central Europe, Japan, New Zealand, and of course Chile, South America. So, and then I looked what is which events are occurring often and which events are so to say possibly popular, easy to get. So basically it's a bright sample with large transits to keep the activities going after the pandemic break, so to say. So this is the list, and I send it to Philip, so they should appear in the ETD in the next days. And they include also some very new toys, like the 5398.01. That is a relatively late edition. So I tried to take something of everything, and something of everything I'll show now in the overview. This is just my background image, because there were such beautiful background images from other places that I thought I should show some Austrian sky too. So there's the north-south distribution of the new editions. So Philip asked me for southern toys. I put in southern toys, so there is even one at declination -80. So it's also it's for quite evenly distributed for right ascension. So we can also go a little bit towards autumn for the observing. And that is the period distribution. It reflects, of course, what TESS can typically harvest. So you have typical periods from a day to about 10 days where TESS is most sensitive, which is good for our practice because the transits are happening often. And but it's not a PLATO situation, but it's good to practice for PLATO because the setup of the individual observation will be very similar to PLATO. But for PLATO, the chance to repeat is often small. So it's good to practice now. And that's another nice image from Austria in the Austrian Alps, the Gegenschein. And that is the distribution, so to say, of the new targets with visual magnitude and the signal depth of the transit candidate, the toy object of interest signal. And you see it's now this is calculated from the TESS magnitude to the visual magnitude. And Hans told me how to do this in a statistical way. So for a main sequence stars, that's the expected correction. It's not the actual correction. For that, you look into the Simbad or another place for the visual magnitude, or the Gaia G magnitude is also probably a good way to look. And you see, I've put in one 7.5 magnitude star with a huge on planetary standards transit depth to give an opportunity for the maybe smaller telescopes. This is maybe the exception to the other toys, because all the other toys are real deal, hopeful, unsolved planetary cases. But this one is an unsolved planetary case, the bright one, but I think it's on an A star. And an A star is not, so to say, it's not hopeful to prove that you have a planet, because the mass measurement will be too difficult with the current practice. Yeah, but the others are all real deal. And then you see they start at 8.5 and go to 11th magnitude. Now the new toys, they tend towards the 10-ish magnitude stars. So that gives you an overview and should produce some nice observing. And the most important thing, because I want to leave some minutes for questions, is the message is here that it's important now that you tell me or the ETD, better to me directly, what you need to do an observation like this PLATO test candidates, to practice for PLATO, what you need, what we should provide from the mission, because I have to require that very soon from the other parts of the mission. So the data will be collected in a PLATO data center, and the question is what information can be provided from the mission to the community that will make your observation easier and maybe more accurate. So that is an information that I would like. So we put this together. Test the toys is the motto, and I have this page set up together to give a very simple description. And of course, the ETD is the communication point. So again, what would you need? Because if I know what you need, we will build a better mission. And there's one thing that is for sure, and that is that PLATO will need you, because we will not have a telescope on every place on the planet to get all the PLATO candidates done. And so there will be a definite contribution to the detection of this one planet. One Earth mass, one Earth radio, one Earth mass, one stage of Earth, and one time the solar mass for the host star. So with that, maybe we can use the rest for questions. And I've prepared much more, but I'll wait for your questions. So thank you.